This conference will now be recorded.
So hello everybody, welcome to this webinar where we're going to give you a taster and a run through the basics on some of the things that are new and different about the ISTQB Advanced Test Analyst course that's been, well, it's 2019, it's 2021 now, but this is the 2019 version of syllabus. So to say hello. So I'm John Young. I'm one of the principal trainers at TSG Training. I've been around a while, been involved in a lot of explaining of testing to people over the years. I've been involved with ISTQB training since the scheme started. And with me today is Bernard. So if you want to say hello, Bernard. Hi, Bernard. Can you hear me okay? Have you got your mic unmuted?
I have now, John. Thank you. Hi, everybody. I'm Bernard. Some of you know me, some of you don't, but I'm the owner and MD of TSG Training, and John has been good enough to work for me for 20 years now. Thank you, John. Back to you.
Thanks, Bernard. So I've got my video on just to say hello. Don't feel obliged to switch your video feeds on. Once I start doing the presentation proper, I'll probably switch my video feed off, because otherwise all you're going to be mainly looking at is my left ear as I look at other screens. So in fact, I'll do that now, if that's okay, everybody. So what we're going to cover in this webinar, we're going to give you a high-level overview of what's changed and why, and I'll talk you through some of the well, not the detailed learning objectives. I'll talk you through the learning objectives and the course content and what's particularly different, and why this qualification is as relevant today as it's ever been. And I'll also run you through a taster of a part of the course. So we're just going to do a mini lesson. I'll explain and demonstrate pairwise testing. So I'm going to show you an application of the technique manually, and then I'll also do a demonstration of how it's used on bigger problems with the tool. And then we'll wrap this session up with some clarity of where this qualification fits on people's career development paths. And so Bernard will talk you through that. And well, we're going to leave this, if you all don't mind, we'll leave questions till the end. So we'll have a Q&A session. So the aim is to do this within a 30-minute session. So without further ado, Bernard, I think you said you'd like to just talk about why the syllabus has changed.
Yes, just a few quick words from me. I mean, it has been around since 2012, the Advanced Test Analyst course, when there was a bit of a bun fight with the ISTQB Practitioner Test Analyst and ISTQB coming out, and ISTQB actually won in the end. But this is really the first major update since it came out, and the reasons it's changed. It was suitable for 2012, but not for today's skills, methods, roles. It's in fact now a shorter, sharper course with greater focus on today's changing methods and roles. Essentially, it's more suitable for what we do today, and they've been good enough to take a day out of it for us. So some of the things that were relevant 12 years ago have been 9 years ago have been taken out. Okay, John, thank you.
Okay, thanks, Bernard. So let me talk about some of this change in more detail. As Bernard said, one of the things that's been quite significant, you'll notice, is it used to be a four-day course, so a day's been removed from the syllabus, and a lot of that's been in reflection. It's very hard to find 4 days out of your work schedules to be able to get the benefit of a training course. So the syllabus has been tightly focused, and so a day's been removed. And essentially what's happened there is, if you think about exams and if you train courses, if you know anything about this kind of things, we're always interested in how many learning objectives are there. So what's been done is, in taking a day out of the course, the number of learning objectives that are examinable has been reduced. So there's 11 less learning objectives than there were in the course previously.
And John, let's not forget this is based on market demand as well.
Absolutely. So the content's changed. So there's been some quite significant removals, and again, a lot of that's come from feedback from the industry about what does a test analyst need, which techniques do you need. So there's been removals of techniques and methods in detail that may have overlapped with other roles like test analyst. Sorry, we're doing test analyst rather like test manager, and removing of any repetition that's unnecessary from things like the foundation. But also there have been some additions to reflect more current up-to-date usage. So the exam has also been changed. It's now, it's the same format. So this is still a multiple choice based exam. So scenarios and example requirements with detail for you to analyze and identify and select the ideal answers. But being a shorter course with less learning objectives, the exam is now an hour shorter than it was before. So it's now a 2-hour exam. And also to reflect that reduction, the exam previously was 60 questions. It's now 40 questions. So it's not like what's been decided is we'll reduce the time, but we'll force people to learn all the same things and test them to the same degree of detail. The aim here is to keep the level of difficulty and the level of content similar in terms of focus and information. Now, in detail, so most of the topics, so if you look at this graphic here, we've got the 2011 syllabus. Now, the topics essentially still in there, but you might have noticed defect management is a discipline which is common to all testers. So that was deemed not necessarily to be refocused on from a test analyst point of view. So that's been reduced, and all areas other than tools and automation have been given a bit more time. So that's been doubled from 45 minutes. And the testing of software quality characteristics, there's more detail gone into that than the past. So we've got some new ideas and some new content there. A lot of it, again, is alignment with standards. And for most of the other areas, there's been a reduction, and this reflects the reduction in learning objectives. So each of these areas, notice testing process is now totally tightly focused on the test analyst tasks and the test process. Test management has now been realigned with the analyst's contribution to risk-based testing, and any other of the general process decision making has been removed. Test techniques, it's still the biggest part of the course, but by the reduction of more obscure techniques being removed, we're still able to give a lot of information over there, those in that area. As I mentioned a few minutes ago, the testing of software quality characteristics, that's been extended. Reviews reduced. So in a little bit more detail, the test analyst's tasks in the test process. So that's also now been aligned with the 2018 foundation syllabus. So one of the challenges has been for people who've come into training courses, particularly over the last year or so, who've been doing the foundation under the more up-to-date alignment and processes, have found they've been having to go back and sometimes read up on theory that is quite old now. So to make things less confusing and more consistent with common practices, more consistent with the reflection with the foundation of, I wouldn't say newer, but more commonly used methods such as agile and iterative and incremental, then the whole content is now being realigned with that process, and also the test activities are aligned that way. And in terms of risk-based testing, this is a much more narrower focus. It's more now aligned to how the analysts get involved in identifying risks, rather than the risk management process, and also repetition from things that were in the foundation have been removed and refined. Now, with the test techniques, that's where we've got quite a bit of difference. So some of the techniques that were in the foundation and were in the have always been in the advanced syllabus, things like decision table testing, state transition testing. There are up-to-date approaches that are more in reflection with how people are applying the techniques in practice on projects. So there are ways that you can see to reduce down and collapse approaches for decision table testing. There's more detail on coverage approaches used in both decision table testing and state transition testing, and there's more detail and clarity in the approaches for use case testing, which are introduced in the foundation course, but now we've got more detail and systematically how to apply them. And when it comes to equivalence, partitioning, and boundary value analysis, this has now been refined to be completely consistent with the 2018 foundation syllabus update. So we're using the same perspectives of applying the approach. We're also using now consistent definitions for the 2-value and 3-value approach. So that makes it easier for people who've done the foundation to make the switch and see consistency. Now, techniques that were in the advanced course previously, which don't get used very commonly, things like orthogonal arrays for pairwise testing, which is quite a more academic approach these days, and cause-effect graphing has now been subsumed within the decision table testing, and things like domain analysis, which are, you know, they're good techniques, but they're very marginal. Not many people use them in practice. So the feedback from the industry was, let's focus on the techniques that are most commonly used. Let's make sure where we're using techniques like decision table testing, we're not just looking at the brute force approaches. So the collapsing options are more detailed. And with pairwise, that's been refined again to reflect the fact that most people these days use tools. And I'll do a demo, little mini lesson in a little while to show you the difference between the manual approach, and I'll also show the tool being applied. So the techniques are being extended to more up-to-date practices, but also focusing now on the things that are more practically used. So we've still got experience-based testing in there. It's still one of the most commonly used from surveys ISTQB have done and other people have done. Things like exploratory testing are as strong and practical to be used today as they have been. So they are still in there. Now, when it comes to the testing of quality characteristics, there's been work done here to make this consistent with ISO 25010. Whereas previously we were using ISO 9126. So the terminology is now consistent with 2510 and is being fleshed out a little bit. In terms of reviews, this has been simplified to take away any extraneous theory, because the 2018 foundation covers review theory and review processes quite thoroughly now. So this has been simplified to reflect the most commonly used specifications and the application of checklists. And then mentioned for tools and automation, there's some more focus here in the test analyst role, in particular with approaches in keyword-driven automation. So that's. I mean, it's very hard to explain how a syllabus that's been changed and updated in a short seminar, and I'm also aware I don't want to be taking too much time. So that's the essence of why the course, or where the course has changed. Now, is the qualification relevant? Well, I'd say test analysis skills are more relevant today than ever. A lot of people I've been talking to, working in classrooms with virtually, certainly over the last year, there's a lot more people now who are taking up the job title test engineer. And if you are working in test engineering, you need a mixture. You need both the black box and the white box techniques and skills. So the things that will come in this course are as applicable, just as applicable in Agile and DevOps. I mean, the difference now is it's the nature of the requirement that's often changed, but also in advanced, we're starting to help people appreciate the modeling skills. So anybody who's moving towards Agile and DevOps, the term model-based testing is becoming more current in the industry. And in interpreting, I've invented a new word, in interpreting requirements and models, these systematic techniques are the building blocks for all both manual and automated approaches. And you can't rely as much on just pure product knowledge. Not if you're trying to scale your work up. Not if you're trying to transfer information and knowledge across your organizations. So the reliance on the reliance on analytical skills is greater than ever, and the return on the investment for putting the work in is. Could you all, just for the time being, if you don't mind, could you just mute your microphones? There's going to be an opportunity at the end of the session for questions. I'm just picking up some. I don't know if it's background noise or background activity going on there. So the qualification and the skills just as relevant. So I'm going to give you a little taster from the course now. So I'm just going to do a little mini lesson on a technique called pairwise testing, which comes under the banner of combinatorial techniques. So if we were doing some configuration testing and we had a new web app and we knew that the basic configuration options were, we've got 3 types of device, we're working on desktops, mobiles, and 2 operating systems. Now, if we were to test this and to exhaustion, if we want to do every possible combination, now I'm using a relatively small example here, but even in this instance, if I wanted to test every configuration option, then there are 18 different scenarios I'd have to test. Now, when we actually look at what happens when we test products, then if we consider the options inside the configurations, if any one of those options caused a failure, so we've got a problem with a desktop PC, then that's a single mode defect. So anything where we use this equivalence partitioning, if we were just looking at one option, one thing goes wrong, then that's a single mode defect. There's one parameter that's caused the problem. And that's fine till we start to get to situations where we've got combinations. But also, if we looked at combining things together, then if we found it's actually one configuration option. So for example, the problems only occur when we use tablets with Android. So it's the fact that tablets interacting with Android that caused the problem. That's what we call a dual mode or a double mode failure. It's one thing interacting with another. So if we were trying to do every permutation, we'd be looking at every combination. But people have done research, and there's reasonable evidence to argue that when you analyze your problems, so when you've done the defect diagnostics, the combinations that we actually need to test may be less than every permutation. So if we look at that as a rationalization for designing tests, then if we just test per combinations, then we need a lot less tests. So if we created a set of tests focused on pairings of options, not every combination, and that was focusing on looking for dual mode or double mode defects, then we wouldn't need 18 tests to invoke those problems. The odds are we can do it with a much smaller test set, and that's the basic rationale behind pairwise testing. So this is a technique where we're using combinations of valid data, but what we're looking for are defects. So we're not using this for positive testing. We're using this to get confidence that combinations of valid data don't cause problems. So this isn't the only method you use when testing. This should be a supplement with tests that are based on what the product should do, our positive tests based on the requirements. So if I wanted to create a pairwise test set, then I'll do this from first principles using a whiteboard. So I've got myself a whiteboard, and on it I've just got the that configuration set of options. So what we have here are, we've got 3 variables. So if I look at the way we can combine these, then the combinations where I could do, for example, is I could combine device and browser. I could combine device and operating system, and I could combine browser and operating system. So if I look at the per combinations, which is essentially what I want the test to cover, then if I look at the combinations of device and browser, then we've got a desktop. So we can combine a desktop with Safari. I can combine a desktop with Edge. And I can combine a desktop with Chrome. Now, if I look at the other options, I've got a mobile. So I've also got 3 combinations for the mobile. So a mobile with Safari, a mobile with Edge, and a mobile with Chrome. And I can repeat that pairing for the tablet. So we've got the tablet with Safari, we've got the tablet with Edge, and we've got the tablet with Chrome. Now, the other combinations I can convert, so I can combine my devices with operating systems. So my desktop, I can combine with Windows and Android, and my mobile, I can combine with Windows and Android, and my tablet, I can combine with Windows and Android. And then the last set of pairings is the browser and operating system. So I've got Safari, which I can combine with Windows, and Safari with Android. And then we've got, what's the other one, Edge with Windows and Android. And we've got Chrome with Windows and Chrome with Android. So this is the mechanical part of the process, is just creating an inventory of the per combinations. So if I tag these, so I'm just going to put indicators on these. So there's my 9 device and browser pairings. And then I've got 10, 11, 12, 13, 14, and 15. So there are my device and operating system pairings. And then I've got, with the next set here, I've got my browser and operating pairings. So to achieve 100% pairwise coverage, I have to cover these 21 per combinations. Now, the test cases are going to be combinations of each variable. So there is no magic formula for working out how many tests you need to create a pairwise test set, because it can differ on how many variables you've got and how many options the variables have. But if I'm doing a bit of combinatorial arithmetic, the good place to start with is pick the first big grouping. So device and browser, they both got 3 combinations. So it's reasonable to assume I'm going to need at least 9 tests. So if I create a table with 9 rows, and I know that's the world's worst straight line, not much better. So what I know, a test case is going to be made up of 1 option from device, 1 option from browser, and 1 option from from operating system. Then the first part of my tests, I'm just going to actually copy the first per combination. So from this table here, so I'm going to put, I'll just do this in a different color. So I'm going to put desktop, and then I've got mobile, and I've got tablet, and we've got desktop with Safari and Edge and Chrome, and then mobile with Safari and Edge and Chrome, and tablet with with Safari and Edge and Chrome. So my first 2 columns, I can now tick off. I've covered these 9 per combinations. So I just need to select my first operating system. So when I add Windows, then I can look back at my coverage here and say, right, well, this covers desktop and Windows. So there's pairing 10 covered, and Safari and Windows, so there's pairing 16 covered. So if I put Android in the next test case, then I'm covering, when I add this test, this extra information, I'm covering desktop with Android and Edge with Android. So now in this case, because I've only got two options, this is a relatively simple one to solve. So if I put Windows in the next test case, then I'm covering desktop and Windows again, but I'm also now covering Chrome and Windows. So pairing 20 is covered. So if I put Android in the next test case, then I'm now covering mobile and Android, that's pairing 13, and Safari and Android, which is pairing 17. So now if I put Windows in the next test case, then we get mobile with Windows, which is pairing 12, and we get Edge and Windows, which is pairing 18. So in test case 6, I put Android, and I get mobile and Android already covered, but I now get Chrome and Android, which hadn't been covered. So what I'm doing is I'm adding something each time to make sure I cross off at least one new pair combination. So if I repeat with Windows, I now cover tablet and Windows, and Safari Windows I already hit. If I put Android in the next row, I cover tablet and Android. And at this point, I've got 100% pairwise coverage. But for my last test case, I need to decide what to put in there. So I can either put Android or Windows in there. Now, sometimes the temptation is, well, I don't need that one. But you have to remember the first part of this test case, it covered tablet and Chrome. So if I deleted that row, I would now not get 100% pairwise coverage. So don't do that. But I can put any valid value in the table. It's important also when you're doing pairwise not to use invalid choices, because if you use an invalid choice, you're going to invoke a single mode failure on the fact that you use something you shouldn't use. So the whole intention with a pairwise test set, as I mentioned, is to create a data set which has got valid combinations, and working on the argument that most defects are caused by two factors together, then that pairwise test set is a set of negative tests using valid data. And I've removed 18 combinations down to 9 combinations. So that's in that case, I've halved the number of tests. It's always important to remember when you do a pairwise test set, it is a negative test technique. I'm not using this to prove it works. I'm using this to demonstrate confidence that these combinations don't cause problems. And I would have to add the expected results. So this is the first part of the test technique being built. Now, I've shown you a simple example. So if I go back to my PowerPoint slides for a second, then if we look at something a bit more realistic. So as we add more variables, the algorithm to solve the problem gets more complex. So here we've got a situation where we've got 3 web servers, 4 browsers, four different operating system versions. We've got 2 video players and 3 media formats. And if I try to do that manually, then that's a bit of a headache. Now, there are 430 possible permutations, and it's not recommended to apply pairwise to large problems. It's time consuming, it's tricky, it's easy to make mistakes. And these days, there are so many tools out there that we can use to solve this problem that we can do it a lot faster. So I'm just going to do a quick demonstration using a tool called PICT, which has been around for quite some time. It's a command line tool. So to use this technique, I've just got myself I've just got a file explorer window so you can see some files. And one of the files in here is called webinar demo. And this is a notepad file. And what I've done in the notepad file is I've hashed out anything I don't want the tool to process. And I've just added each of the variables with a colon and then comma separated the options. So I've got my web server with 3 options. I've got my browser with 4 options. I've got my operating system with 4 options. I've got my video player with 3 options and my format with 2. So you're just transcribing the problem into a text file, colon separate the variables, comma separate the configuration options. And then with this tool, once it's installed, I simply type command PICT, name the file I want to process. So in this case, it's called webinar underscore demo.txt. Then just pipe the output to the file. So I'm going to do it to jy friday.xls. Cross your fingers. I've called it jy_fid. It doesn't really matter. Hope it works. And in this file explorer, we can now see JYFID XLS. This Excel spreadsheet's been created. So if I open that in Excel, and Excel will complain because I'm using an older format. And there's a set of, what was it, 17 test cases. Now, again, as I mentioned before, this is a negative test set. This is a set of combinations of valid values that if you run these tests, and you get a problem, it's going to be probably a dual mode problem. If it passes, you've got a reasonable degree of confidence that the problem, those configurations are being processed correctly. Not so much correctly unless you put expect rules that don't cause a problem. So I'm just not going over the time. That was just a quick demo of pairwise testing. Now there is a variation. It's called N-wise. So with tools, we can often go, if we think dual mode's not rigorous enough, then we can go for three wise, and the algorithm will do every triple. Or you can do 4 wise. It will do every quadruple of combinations, and it will still good. The tools will still create a much smaller set of combinations, but doing 3 or 4 wise manually is definitely not recommended. So just a word of time. So I'm going to pass over to Bernard.
Okay, John, thanks for that. That's very thorough. Press enter, please. I won't labour this too much. It's a 5-stage plan from TSG to develop you as a professional tester. And we see this course sitting in the test engineer stage to the senior test engineer stroke team leader. Again, I won't cover any more of this. This will be in your slide pack, and it's available online from our website. If you'd like to register, the entire program is there, including all the backup that goes behind this stuff. So thanks very much, everybody. John, back to you to see if there's any questions, please.
Okay. Yeah, so anybody got any questions?
I'm guessing not, John.
Okay. Well,
Nope.
Well, thank you very much. It'd be nice to see you on the Advanced Test Analyst course in the future.
Can you hear me?
Oh, hello. Yes.
Yeah. So someone who was, oh, sorry, I've got a lot of feedback. Can you hear me? Yeah.
Yeah, I can hear you. Okay. Yeah. Thanks.
Yeah. If I'm interested in this course, but do I need I don't do any automation at the moment. Do I need to be doing automation in order to understand the automated section?
No, because the whole idea of this is we're talking about the test analyst role in the automation process. So we're going to be talking about this from the test identification point of view, and how you then would work with the automation engineer. So we look at the automation side in the Advanced Technical Test Analyst course and in the Advanced Test Automation Engineer course. So this is from the other side of the conversation's perspective. So you do not need to know hands-on or theory. Well, theory of automation is useful, but you don't need to have any hands-on experience for this course. Absolutely not.
Okay, great. Thank you.
You're very welcome. So Liam is saying, how does this compare with Test Automation Engineer? Well, Test Automation Engineer focuses primarily on the process of getting the architecture of your automation solutions designed for a sustainable solution. This course, in common, that talks, when you're the automation engineer, you're talking more about how do you make the test work. What the test analyst is doing is organizing what does the test represent. Does that make sense? And Atab, you said the Depict tool, is it open source? It's, if you went to, there's a website called, hang on, just grab a pen so I can write this on this slide. So there's a website called perwise.org. and they are they promote all things pairwise, and they've got an inventory of commercial, open source, and free tools. PICT was devised by the Microsoft test team and then made available as a command line tool. So, so back to Liam, would you have benefit in attending if you've got the test automation engineer, if you're going to be involved in making sure the tests you automate have business relevance, then absolutely you'll find benefit in this. And if you want to then be able to help sometimes business people translate the test conditions into things that are automatable, then this would definitely be a benefit. As I said, a lot of people sometimes focus, when you talk about test engineer, they focus on the technical side of the engineer role, but we need that understanding of what testing is actually trying to achieve in terms of business outcomes of the systems as well.
Okay, John, thanks very much, and thanks to everybody else for attending. We know we've been a bit longer. Oh, Darpan's got a question for you, John, quickly.
Oh, sorry. The difference between this course and the technical test analyst course, the intention is in splitting the syllabus was we're focusing primarily on black box with this course. In the technical test analyst course, we look at the white box. We're looking at code-based. We're looking at the non-functional attributes that are more behind the scenes and require more technical insight. So we're looking at non-functional, and we're looking at some of the more technical considerations on the automation side as well. So the intention with the two syllabi is that they complement each other, and there's minimal duplication.
Looks like we're done, John. Thanks very much, and thanks to everybody for coming today. We hope to see you soon. Have a great day. Thank you.
Okay, thanks.